All right, JT, listen, we're going to be talking about welding today. We're just going to go over the basics of welding. My goal is to kind of help you take all the fear out of welding, the mystery, just to get you started. So why welding? Well, I've always believed there are kind of three basic skills you need around kind of working with stuff. You know, if you own a house, you just got to be able to work with wood, concrete, and steel. There's some other things too, but those are three things. If you can attach wood to wood, wood to steel, steel to wood, steel to concrete, concrete to steel, concrete to wood, if you can do that, you can basically build a house. But welding is, as I found, is easy. It's really easy. Welding well is an art, which takes years to perfect. We're gonna go over the easy part, just melting two pieces of metal together, and talk about how that works. So the basics of welding is basically heat with an arc, electrical arc, like you put two wires together that shock or make a spark. That's the arc we're talking about, and that's how we weld. You need filler metal, and that usually comes in the form of a wire or another piece of steel that you melt to the steel that you're welding, and then a gas or a flux. The purpose of that is we're trying to keep oxygen out of the weld, because oxygen in a weld makes metal brittle. So you've seen like tanks on welding equipment. Those are either carbon dioxide, argon, or a mixture of the two. Those displace the oxygen from the weld to make a clean weld. Flux is another replacement for oxygen. Again, taking the oxygen out. I'm sorry. Flux takes the place of oxygen when you don't need the gas. All right, let's talk about the types of welding that you can do typically at home. So there are three basic ways to weld. There are lots of ways, but three basic ones we're going to talk about: stick welding, MIG welding, TIG welding. Stick welding is probably the oldest type of welding. Basically, you take an electrode, you've got an electric circuit, plus and minus. You've got an electrode coming off it that's wrapped with flux. You tap it to the metal, creates an arc, and you start welding. I mean, it's as simple as it gets, but the flux on the metal rod displaces the oxygen, so you have a clean weld. And then the second kind, MIG welding, which we're going to do a little later today. MIG welding, same idea. Basically, you're creating an arc with the plus and minus of your electric charge, but this time it's a little bit more controlled. You've got a gun that pushes out a wire, and that wire creates the arc. And then there's two ways to get rid of the oxygen. One is you can have gas that floods that area to get rid of the oxygen, or you can have flux in the wire that as it burns, as it creates that arc, the flux displaces the oxygen, so you have a clean weld. Third kind is TIG welding. TIG welding, certainly at a higher temperature, there is no flux involved with that. It's typically gas only. Makes a cleaner weld, much more focused. There's a real art to TIG welding. We won't get into that. I don't even do it. It takes an artist to do that, TIG welding, in my opinion. But TIG welding is a much cleaner weld. Stick and MIG welding can be a little messy if you're using flux, because flux splatters and then you end up cleaning up. But it's just an easier way to weld, especially if you're not doing anything too artistic, or maybe stainless steel, where it just has to be beautiful. The different applications is, think about it this way. If you're using gas, you probably want to be in a controlled environment where the gas won't blow off from the air. So if you're outside on a windy day, using gas can be more difficult to get a good weld. You'll probably want to use a flux-based weld, which would be stick or MIG flux core. If you're indoors, great to use, gas, of course, with ventilation, but that creates a clean weld. You're not blowing away the gas. But if you're outside and you're working on the farm, or you're working on your fence, or whatever like that, stick welding or MIG welding with flux core wire works great. So there's two groups of welding machines you can buy. We're talking about consumer, and we're talking about like the home do-it-yourselfer. So there's ones that run off of a 110 volt, which typically in your house, or 220, which you need an upgrade, of course, to your outlet. That's the kind that works for your dryer. The reason being, a 110 will get you about 135 to 140 amps max on your welding machine, which really will help you get to about a 1/4 inch of metal if you're going to go that thick. 1/4 inch is pretty darn thick. And you're going to need a 20 amp breaker. For higher voltage equipment, the reason you might want that is if you're doing a lot more work, you've got a lot of welding to do all at once, you need a lot more heat, and you're working with thicker equipment or thicker metal. So let's talk about the machine variables. When you're looking at machines, and we can talk about a couple of those, is you're kind of concerned with the voltage in and the amps out. So today I'm going to use a 110 machine that I got I got it on Facebook Marketplace, but it's a Harbor Freight Chicago electric welder. It's a 110 volt, and it goes up to 115 amps, which is plenty for the stuff I'm doing around here. I'm probably going to upgrade soon, but for the stuff we're doing today, it's plenty. Duty cycle. That's an interesting topic. So duty cycle tells you how long I can weld continuously within a 10-minute period. So this welder that I'm going to use has a 20% duty cycle. That means for every 10 minutes, I can only weld 2 minutes continuously, then I've got to let the machine rest. So better equipment will give you a longer duty cycle. A higher voltage equipment on a lower amp output will give you a longer duty cycle. So the higher the amp output and the lower the voltage input will create a much lower duty cycle. So keep that in mind. For a 20% duty cycle, I haven't had a problem because I'm usually welding for 30 seconds at a time. I'm messing with my equipment and then, or my material, then I'm doing something else. A couple other things you want to look for is the quality of the build of the equipment. So, cheaper equipment, maybe a cheaper build, maybe more molded plastic on the inside. The spool, because it feeds, a MIG machine feeds a spool of wire through the gun. Sometimes that's plastic, sometimes those parts are made out of metal, sometimes the gears and the wheels that kind of move the wire through are plastic. So you just want to look at those things. Better ones are just made better. Does it have gas input? So, as I mentioned, there's flux wire, and they call it flux core wire, and then there's regular wire. The regular wire requires gas. So my machine does not have gas input, so I'm only going to be doing flux core wire welding. But you might want one where, if you want a cleaner weld, you get one with a gas input, so later you can try using with gas. All right, another thing you want to look at is a variable speed wire control. So on mine, I've got wire speed control. So I can adjust the amperage and the wire speed. Why does that matter? Well, wire speed, think about it this way. If you've got high amperage, high heat in your welding, it's going to use up that wire faster, okay? If I'm working with thin metal, I don't want to spend a lot of time in one spot putting a lot of metal on that. I probably want to move faster, right? So I want a higher wire speed while I'm moving fast to distribute that wire while I'm moving quickly. If I've got thick metal and I'm trying to put a lot of heat there as well as wire, I'm probably going to slow my wire speed down because I'm focusing my heat in one spot. It's getting hot, hot, hot. I'm getting hotter and hotter because it's so thick. I need more heat on it longer, and I'm distributing a lower amount of steel or wire as I'm working my weld. Okay, that's kind of the basic philosophy there. And then, of course, variable amp. So you want variable wire speed, variable amperage output. can be what might be important. Some of them have a fixed amperage, some of them have, and then they just let you deal with the wire speed. Some have variable amperage. Most of them come with a panel on the side that you open up, and it'll show you, hey, for this thickness of steel, use this kind of wire at this speed with this amperage. So that they're all pretty self-explanatory. Most of the time they come with that. And then some of them are multifunction. So some machines do just MIG, some just do MIG flux core, or MIG flux core and shielded gas with the gas input. Some do MIG and TIG, some do MIG, TIG, stick. Some can each also have a plasma cutter on it. So it seems like the more multifunction they are, maybe they're not as good as one thing, but you know, I don't know. I haven't used enough of them to figure that out. Again, this is just kind of a basic introduction, but there's a lot of different tools out there that you can try. And then some of the makers that I've found is, you know, Lincoln Electric is you know, solid. Same thing with Miller Electric. Hobart is a good consumer product that has a great reputation. There's Eastwood. Titanium, that's the Harbor Freight version. Yes Welder is something that I came across recently that has pretty good reviews. And then Forney, F-O-R-N-E-Y, that seems to be a pretty good product as well. All right, so let's talk about protection equipment. And I'm going to show you some protection equipment. I'm going to show you my all the other equipment that I use for welding, and let's get to those now. Here we go. Another thing I want to show you, we talked about duty cycle. There you go, there's the duty cycle. 20% duration of use at 90 amp setting for every 10 minutes. So 2 minutes of welding, followed by at least 8 minutes of off duty cycle. So look for that in your welder that you're going to buy. All right, some protection equipment. Of course, I've got some really good gloves. I think I got these at Home Depot. I think you might also be able to get them at Harbor Freight, but you probably won't get that little logo on there. So I think I actually got these at Home Depot. 15, 20 bucks, I think. Helmet. All right, so what I would recommend is an auto darkening helmet. So you can get a helmet that's already dark glass, so that when you put it on, you can't see anything. When you strike the arc, of course it's bright, and then it's already dark, so that you can see the weld and not hurt your eyes. Auto darkening is, if I put this on now, I can see regular, like I'm wearing sunglasses, but as soon as I strike that arc, it has a light sensor in there and it immediately gets dark. Gosh, it gets dark like in 0.01 of a second. So now this welding helmet is from Yes Welder, and I got this on Amazon, and I think I got it for like 35 bucks or 40 bucks. Maybe it was on sale for 35. It's been great. Okay, so I'm not welding every day. If I was welding every day, I'd get something a little more durable, probably run me 100, minimum 100, probably more like 150 to 200. There's some really nice helmets out there. But this one has served me really well. It's a little bit flimsy, but it's comfortable, it's light, and it's auto darkening, and I think that's really important. As far as clothing, you know, I'll wear this. I've got my glasses because I can't see without them. I'm wearing a pretty heavy cotton, what is this? This is a Carhartt, pretty heavy shirt. And then I've got almost, you know, they're not leather, but they're very heavy, like jean type pants and leather shoes. So, you know, we're spitting out a lot of sparks. It's hot. You know, if you're wearing nylon, it's gonna melt anything that you're wearing that's nylon. So I just wear some heavy protective clothes. Think about the sparks that are probably gonna fly over your head. I've got them on the back of my head. So this is pretty good to cover your head for all those crazy sparks. So that's kind of the basic for the welding protection equipment. All right, let's talk about some of the equipment that I use while I'm working with the metal and getting ready for welding. Definitely gotta have gloves. I usually need these for handling the steel. It might be warm, sharp edges. Always wearing gloves throughout this whole process. Pliers, definitely need those when the steel's hot, as well as for cutting your MIG wire as needed. Caliper, to know what thickness of wire you have. This is great for getting the right angle. This is digital. Got that at Harbor Freight. I think I got it for like 12 bucks. And it tells you digitally what the angle is that you're working with. Clean up your workspace. All right, I've got 3 angle grinders. So I've got 3 of them because they have 3 different uses. and I'm constantly going between the three of them, depending on what I'm doing. So I've got a cutoff wheel here to cut through the steel. This one is to clean it up like a sander. It's a wire wheel, and this is a flap. What do they call that? A flap grinder. So this I can strip down and clean up the steel that I'm working with, and to get off some of the maybe flux. This, if I've got to get some rust off, maybe I'm getting in a corner and I can't get to it with this. This I can actually mold and kind of sand off a corner, while this I'm going to kind of get into kind of areas to get some rust off. But this is, I'm cutting through steel with this. I can use these. Get a bunch of them. I've got like 10 of them here. You go through those pretty quick. Here's some other wheels. That's a smaller grinding, flap wheel like this if I want to use it. Here's a shaper. I would use that to kind of shape off maybe round corners if I want to. Definitely wearing goggles while I'm working with this, because it blows off a lot of sparks. Various vices and clamps to clamp down my work while I'm either working on it to cut it or to weld it. These are pretty handy. These are magnetic 90-degree angles, and so this can hold your steel in place while you're working with it. What else? Oh, and this table. I actually got this table. It is a Harbor Freight table. I got it from off Facebook Marketplace. I think the guy threw it in free because I bought the welder from him, so he gave that to me. But it turned out to be a lot more handy than I thought. So you can connect your negative to this while you're working on welding on this table. It's awesome. All right, let's look at the welder. All right, this is my welder setup, and actually simple welder. It's a 110 volt Chicago Welding machine, and it's got my wire speed right there, on and off, minimum and maximum amperage output. And I usually just keep it on max. This holder, this welding cart, is a lot handier than I thought it would be. So I'm glad I got that. Again, I got that on Facebook Marketplace pretty cheap. I've just got some extra parts down there and some extra wire. Here's that flux core gasless flux core welding wire for this welding. So I've got a ton of wire left. Here's the gun. Very simple. I'll turn this on here in a second and I'll show you how it works. All right, I'm going to run through a real quick example. I'm going to, I've got a 2" by 1/8 inch piece of steel here. I'm going to cut it. I'm probably going to make a couple cuts. And then I'm going to clean it up a little bit. And then we're going to weld it with All right, I don't know if you can see the difference between these. So this was, you can kind of see that edge. All right, so that's just cut without any cleaning up. Here's a cleaned up edge. All right, so that's gonna be a lot easier to weld with without all that crap on there. Plus, all that stuff, man, I'll just get that's a steel splinter waiting to happen in it. Hey, one more thing. Always good to clean up the the edge that you cut, I mean, like if this is the scrap that I'm not going to be using for another, whenever, next time I'm going to weld, clean up the edge, because while you're storing it, you just don't want it to get cut on it later. Little tip. All right, let's get to welding. So what I've done is I've turned on the welder. Let it warm up a little bit. There's the electrode. Now watch when I pull the trigger. See how that wire comes out? All right, so that's ready to go. I'm gonna clean this up. Take a little bit off the end. I'm gonna set up my my job that I'm gonna do. So I'm gonna do a T-weld. So say I wanna do this kind of angle. So this is just real basic, right? I wanna put that right there, and I want a 90-degree angle. That's what these are for. Got it nice and secure there. Do it right here on the end. All right, so that looks like it's, I'm gonna say it's pretty close to 90 degrees. That's what that clamp, this magnetic clamp is for. Get me right to the 90 degrees. Set it up just the way I want it. And here's what I'm gonna do. I'm gonna hit this with a tack. Just a quick little tack on both sides. And then I'll check that out, make sure it's the way I want it, and then I'll finish the weld. Here we go. All right, so that bead is a little bit chunky, not very pretty, but I cleaned it up. It doesn't look like horrible, but it's gonna work great. Let's look at the other side. So what I noticed while I was welding was that my welder seemed to be stuttering. So I think I might have a wire feed. So what was happening was where it was coming out, then it stopped, then it'd come out a little bit more, and it'd stop a little bit. It was kind of stuttering as it came out. So that means my weld would start and stop because the arc would break, and then so it got a little bit more chunky, as you can see on that weld. If I had a smooth feed, and I had it on pretty low, if I had a smooth feed, I would have been able to lay down a cleaner bead. So maybe I just need to either clean up my equipment, or maybe I just got crappy equipment. But let's give it a test. Here we go. We're gonna give it the hammer test. Here we go. This is actually bending my steel plate more than it's bending the weld. All right, so for a functional weld, that held up pretty well. It still has its 90-degree angle, even after banging it with that hammer. And that literally took me just a few seconds on each side of that weld. So that's gonna be a strong functional weld. Now, like I said, welding is easy. Welding well is an art. And it just takes a lot of time to clean up those welds, maybe go slower. I could have done a slower wire speed and moved down my that angle there slower, and probably put more material there. I can grind that down some more to make it look better, but frankly, I don't care if that's a functional weld for something that maybe I'm going to paint over, or maybe you won't even see it. So let's go do the lawnmower and see what happens. Here we go. All right. Hey, so this is a real simple and very practical application of why you might want to learn to weld. So here's my lawnmower, and this whole thing broke. I don't know, this broke last year. I've been kind of limping along with it, but I'm like, I'm kind of tired of that thing being broken. So what I'm going to do is I'm going to come in here. I'm going to get my either my grinding or my that wire wheel, and I'm going to clean all this up. I'm also going to try to get the paint off, because when you clamp on your welding, you don't want to have to weld through paint, and it's really hard to get to weld through paint because that's not a great conductor of electricity. So we're going to clean all the paint off all this area here, mostly right in here, and I'm going to get some way to pull that together, and I'm going to weld that gap together, and it really won't take long to do that, and then it'll be as good as new, probably stronger than the surrounding steel. So we'll get to that in a few minutes. All right, so while I was cleaning this up, two things. I saw another crack up here, so I'm just going to go ahead and tap that together too, weld that together too. And then here, you can see I cleaned this part off because I need a clean area to connect my negative to. I'm going to put my negative here, I'm going to weld right here. So with the paint in the way, it doesn't create a good connection, and I won't have a good circuit to break my arc. So, and then when I'm done with this, after it's welded, I'm going to paint all this stuff. Just clean it up, it'll be fine. Here we go. All right, so I don't like what I did here. This tacked pretty well down here, but it ate up some of my metal here. So a little trick I've learned is I get a nail, I'm gonna put that nail right there, and I'm gonna weld that metal into that gap, and then I'm gonna cut it off and sand it down, it'll be just fine. So let's give that a try. All right, I think that's gonna work. All right, so, that looks pretty good. Very simple, functional. I'm not trying to make a piece of art here, but I am trying to give my lawnmower a couple more years of life. So sprayed it with some Rust-Oleum to keep it from rusting. Kind of a flat black paint. It's my lawnmower, so I'm not going to be too worried about what it looks like, but it's going to work just fine. All right, so what did we do today? We did practice weld, T-weld on some scrap pieces of metal, and we fixed my lawnmower, which was great. So now I've got a lawnmower that won't fall apart on me. So we used a piece of scrap metal as filler, welded it in there, sanded it down, painted over it. It's going to be good. Not good as new, but it's going to be great for a couple more years to come. So how hard can it be to weld? Well, it's pretty easy to weld, but it's very hard to weld well, as you can tell. So a lot of practice. I'm definitely going to need a lot of practice. Maybe some upgrading the equipment wouldn't hurt. So thanks for joining me. We'll see you on the next one.